Einstein's general theory of relativity itself predicted that space-time began at the Big Bang singularity and would come to an end at either the Big Crunch singularity if the whole universe recollapsed, or at a singularity inside a black hole if a local region such as a star were to collapse. For understanding quantum aspects of the origin and fate of the universe, we must first understand the generally accepted history of the universe. This assumes that the universe is described by a Friedman model. In such models, we find that as the universe expands, any matter or radiation in it gets colder. At the Big Bang, the universe is thought to have zero size, so it would have been infinitely dense and hot. At this time, mostly photons, electrons, and neutrinos would have existed with their antiparticles. Neutrinos are extremely light particles that are affected only by weak force and gravity. As the universe expanded, the temperature dropped and the rate at which electron-anti-electron pairs were produced in collisions would have fallen below the rate at which they were being destroyed by annihilation. Most of the electron and positrons would have annihilated with each other to produce more photons, leaving only a few electrons left over. Neutrinos and antineutrinos wouldn't have annihilated as they interact with themselves and with other particles only very weakly. In 1948, the famous paper was written by George Gamow and Ralph Alpher that made the remarkable prediction that radiation in the form of photons from very hot early stages of the universe would be around today, but with the temperature reduced to only a few degrees above absolute zero. This radiation was discovered by Penzias and Wilson in 1965. At the Big Bang, some quantum fluctuations might have occurred, as if these hadn't occurred, why would there be some regions denser than the others? As hydrogen clouds collapse, gravitational pull of matter outside these regions might start them rotating slightly, hence formation of spiral galaxies. And everything you see today is the result of those quantum fluctuations.